Hi everyone, welcome to today's lesson. Today is the first lesson for transformations. We're going to be talking about the 6 basic graphs that we're going to be seeing all throughout this unit and throughout Math 30-1. The very first graph that we have here that we're going to be talking about is f of x equals x. This graph is from Math 10C. It should be very familiar to you. This is what we call a linear graph, or a linear line. The way that we start to solve this question is we're going to give you all the x values. You're going to sub that in for your y values, aka your f of x values. So if you start subbing it in, you get the following. So if you had -2 for x, that's going to equal -2. No change there. So let's get going here. Here at x equals -1, we have a y value of -1 as well. Again, 0 is going to go here, 1 and 2 respectively go down here. The next three questions here, this first one is asking you, is this a function, yes or no? This is a simple yes or no question. To solve that, the easiest way to figure that out is if we actually graph it out. We have a test called the vertical line test that we can perform to figure out if this graph is a function, yes or no. The next two, domain and range, we'll deal with once we have a graph. It's a bit easier to visualize your domain and range once you have a physical graph. To start this off, I'm going to put a coordinate dot at 0, 0, because that is one of our coordinates, 0, 0. Put a nice big dot there. At 1, 1, I have a dot there as well. And at 2, 2, I also have a coordinate there. Move into the left a bit. We have coordinates at -1, -1, and at -2, -2. 5 dots is usually more than enough to create any sort of graph, to create any sort of line. So I believe that should be good enough. I'm going to try my best to connect the dots here. And there's my graph. On the ends of my graph here, just please be aware that I am going to put little arrowheads here and down here. These arrowheads denote that this graph is going to go on forever. So now that I have my graph drawn on this grid here, Cartesian plane, I'm going to figure out, is this a function, yes or no? Again, the way that we figured this out is using a vertical line test. Basically, we're going to draw a vertical line, vertical meaning up and down, vertical line, and we're going to move from the left to the right of this graph. As long as that vertical line only touches this graph on one point, it is considered a function. If it touches this graph more than once, it is not a function. In this very first example, yes, this is a function. We're going to start talking about our domain. So to figure out domain and range, we always use curly brackets. So I'm going to start by opening up a curly bracket, writing x and a line meaning x such that. Well, we're going to describe what is happening on our x-axis, going left and right. Domain is always left to right. So going as far left as we can go, it's going off to -infinity. As far right as it can go, it's going off to positive infinity. The way that we can write down our domain is it's going to be x such that x is an element of a real, meaning that it is every x value that you can think of going as far left and as far right as you can go. For our range, we're always going to look from the very bottom and going up on our graph. So at the bottom of our graph, the lowest number that we can go, because this graph goes on forever, is -infinity as well. The highest that we can go is positive infinity. So again, to set up my range, I start off with a curly bracket y such that y is an element of a real. And by the way, this r is a r with a double line there. This is pretty much our first example here, our first graph that we have to work with. By the way, these curly brackets, this type of way that we write domain and range, this is what we call set notation. The reason why I'm mentioning this is there is a second way that we can write down domain and range. It's sometimes a bit faster. It could be considered almost a shortcut to writing down domain and range. It's called interval notation. So I'm just going to do an example of interval notation for every one of these examples, I'm just going to do it slightly below here. So interval notation. The way that we're going to set up interval notation is you use either rounded brackets or square brackets, and I'll talk about the difference between each in the coming examples. So for interval notation, it's always going to be your minimum value, comma, your maximum value. So minimum value, comma, your maximum value, and that's how you kind of build interval notation. So I'm going to set up my domain, interval notation for domain, and interval notation for my range. For my domain, again, we're going as far left and as far right as we can go. Well, the furthest left that we can go, we mentioned earlier, was negative infinity. The furthest right that we can go was positive infinity. Infinity is a number that you can't actually truly imagine or can't contain. You don't ever include it in your answer. So I'm going to use rounded brackets because I do not include infinity in my answer. I don't know what infinity truly is. For my range, I'm going to ask myself the same question. How low, how high did this graph go? Well, the lowest we went was negative infinity. The highest we went is positive infinity. And again, I'm going to use rounded brackets to denote that we do not include infinity in our answer. This is our very first example. In the next example, we have an equation that's f of x equals x squared. In this example, this graph is what we would call quadratic. So I'm just going to type that above. Quadratic. So for a quadratic graph, again, this is a graph that you're going to look for a U shape. Usually either your U shape is going to open up or it's going to open down. In this case, it's a positive x squared, so that means I have a parabolic shape opening up in the up direction. So to fill out my table of values again here, I gave you all the x values, and we're just going to start by filling out all our y values. If you had negative 2 squared, and again, this is the same thing as saying negative 2 times negative 2, two negatives will make a positive, so we have positive 4. Again, you could use your calculator to calculate that, or you can just use a bit of math multiplication to get to that same answer. Negative 1 squared is going to be positive 1, 0 squared is 0, 1 squared again is 1, and 2 squared is positive 4. Again, I'm going to start off by graphing as best as I can. I'm going to jot down all my dots. So I have a dot at 0, 0, a dot at 1, 1, and a dot at 2, 4. On the other side, to my left, I have a dot at negative 1, positive 1, and a coordinate or a dot at negative 2, positive 4. Here, you're going to try your best to connect your dots. I'm using a little sketch pad today, so my dots might not connect as nice, but we'll try our best. So, and you kind of want to get a bit of a curve on there to connect your dots. And that's half my curve there, and the other half is going to look something like this. Kind of a little jaggedy, but that's okay. That gets the idea across, and it should kind of form a U shape. So there's my graph. To answer this question here, function notation, is this graph a function, yes or no? Basically, again, you're asking yourself, if I drew a vertical line and I moved it left to right, would I ever cross this graph more than once? The answer here is no, I don't ever cross it more than once, so yes, this is a function. What's my domain? Well, how far left and how far right do we go? Well, as far left as we can go is negative infinity, as far right as we can go is positive infinity. This is what we call x is an element of a real. For my range, I actually change up my range just slightly in this example. So my range, I start off with the curly brackets y such that, well, what's our lowest value that this graph goes down to? The lowest value is right here, which is a y value of 0. So as low as we can go on our y-axis was 0. The highest we're going to go is positive infinity. So I'm going to set up something that looks like 0. Y has to be greater than or equal to 0. But what can y be once you're greater than this first condition? Y can be an element of a real. Y can be every number that's going to be greater than or equal to 0. Here we have our set notation done. I'm going to write down the same answer using interval notation just in case you ever run into interval notation. So again, domain and range, but this time in interval notation. So interval notation time. How far left, how far right are we going for our domain? We're going as far as negative infinity all the way up to positive infinity, rounded brackets on both of them. For our range, as low as we can go was 0, and as high as we can go was infinity. Again, once I say infinity, rounded bracket. In this case here, because 0 is an actual number that we have a coordinate on, it is a number that we want to include in our results. I'm going to use a square bracket to denote that we are including 0 in our answer. In the next example here, example 3, this here is f of x equals x cubed. This is what we call a cubic graph. And of course, I'm going to start off by filling in my table of values here just to see what we end up with. So if you have negative 2, you're going to cube negative 2 on your calculator, or negative 2 times negative 2 times negative 2, you're going to multiply it out 3 times. That's going to get you negative 8. Negative 1 cubed is negative 1 still. 0 cubed will still be 0. 1 cubed is 1. And 2 cubed, positive 2 cubed, that is positive 8. Again, I'm going to try my best to graph all of these points. If you notice, I can graph 0, 0 for sure on this grid here. There's a origin there. You can do 1, 1, and negative 1, negative 1. So basically, those are the only 3 dots I can try to graph. At 2, I'm all the way up here. I'm off the grid. It's going to be positive 8. That's way off the grid here. And at negative 2, I'm all the way down here. I'm also off the grid. So I'm going to just try my best. Usually we're looking for 5 coordinates, but I am just going to try my best to see what this is going to look like. So I'm going to draw, basically, it's going to look like half of the letter U going up. And try your best to connect your lines there. Mine's slightly crooked, but that's okay. Then half of a U going down. And again, I don't want to quite cross my x equals 2, this x equals 2 line just yet, because it will cross down here at y equals negative 8, somewhere down there. Again, I put arrowheads denoting that this graph goes on forever. If we take a look at this function, is this a function, yes or no? The answer here is yes, this is a function. What's our domain on here? Again, we're going as far left and as far right as we can go. So what this is, again, x is an element of real, denoting that it's everything you can think of. For our range here, we have as low as we can go was negative infinity, as high as we can go positive infinity. Again, it's one of those YER situations. Y can be any real number. Again, I'm going to double up and write down my interval notation for domain and range, just on the off chance that you ever see it. So again, for interval notation for domain, the lowest we're going to go is negative infinity. And the moment I write down negative infinity, rounded bracket right away. Positive infinity, rounded bracket, because we're going to go as far left and as far right as we can go. For our range, negative infinity to positive infinity as well. Again, rounded brackets, because that's as far down and as far up as we can go there. In this next example, this graph here is not the same one that you have in your notes. I do know that, and I apologize that I didn't get you the same graph there. On this graph here, though, I did need to change it up, because this equation here, f of x equals square root of x, this is what we call a radical. So you're graphing a radical, basically, okay? So to graph a radical here, what do we need? Again, it's easiest to start off with a table of values, and you're basically asking yourself, if this is my x value, if I sub it into this equation, can I square root and get an answer? Well, let's double check on our calculator. If I square root 0, I'm ending up with 0 on my calculator. If I square root 1, it's still 1. If I square root 4, though, this time, I'm going to end up with 2. Square root of 9, of course, is 3. And square root of 16, of course, is 4. We have enough here, enough data points that we're going to try our best again to graph as many of these dots as possible. Again, I'm going to put a dot at 0, 0. And then I'm going to keep building at 1, 1. I have a dot there. At x equals 4 and y equals 2, so I'm going to try to scroll down a bit further on my grid here. X equals 4 is right here. Y equals 2 is right around here. I put a dot there. At x equals 9, y is equal to 3. And of course, at x equals 16, all the way close to the end here, y equals 4. Again, I have quite a number of dots. I'm going to try my best to draw a line or sketch right through them. So here we go. And it should basically look like a sideways U, or at least half of a sideways U opening up here. And there we go. I'm going to draw a little arrowhead on there. So this, by the way, this front end here closest to the origin, this is curved. It's going to start off on your curve. It's going to curve this way here. Okay. Notice here, just an FYI, that we usually start all radicals at 0. There's no negative numbers here for x's. Why is that? You cannot square root a negative number. It just doesn't work on your calculator. Your calculator should error out. That's what we call an imaginary number. You'll learn about that in calculus or sometime in your future once you move on to higher level mathematics classes. Very first question here, is this a function? Yes. Because if we did a vertical line test, again, that vertical line test is only going to pass through this graph one time ever. And so yes, it's a function. What's our domain here? Our domain, I'm going to start off with my curly brackets, x such that, well, what is x? The furthest left that x went was 0. The furthest right that we're going, well, there's an arrowhead over there, so we're going as far right as possible. So I'm going to set up x has to be greater than or equal to 0. But what numbers can x be after that? X is an element of a real. So x can be every real number that's bigger than or equal to 0. For my range, my y values, so how low, how high are we going? The lowest we went was 0. The highest we're going is, again, infinity. So we're going to set up y has to be greater than or equal to 0 as our first condition. Our second condition, y can be an element of a real. Y is an element of real, meaning y can be every number bigger than or equal to 0, whatever you can think of. Fractions, decimals, usually are in there. You can pick whole numbers, whatever you can think of, really. Real number is every number. Again, I'm going to set up my interval notation for my domain and range here. So domain, range, right below. Domain, how far left did we go? Well, we went as far left as 0. We want to include 0, so I'm going to use a square bracket. How far to the right did we go? We went to positive infinity, rounded bracket, because it's infinity. How low did we go for our range? The lowest we went was 0. How high did we go? Well, again, the highest we're going to is infinity. Again, once I see infinity, rounded brackets right away. In example number 5, this is what we call a reciprocal function, or sometimes this could just be clumped in with a rational function. So reciprocal, or sometimes it's called a rational function. Okay, it's one or the other name, and both are interchangeable basically. In this example here, notice that our numbers are kind of wonky. We're giving you x equals -2, -1, -1/2, 0, positive a half here. I'm going to move on as well. I'm going to add on a few extra dots here, or a few extra coordinates actually. Let's add on +1. That's the only one I can kind of fit there. And if I could, I would really try to fit on +2 as well there. It just makes your graph a bit more full. Again, we're just going to take our x values, sub it in here. So if I had x value of -2, 1 divided by -2 is just -1/2. In this case here, To graph a fraction kind of tough, so I'm going to switch it over to a decimal. So negative half is the same thing as saying negative 0.5. 1 over negative 1, of course, is negative 1. 1 over negative 0.5. This one might be a bit tricky. You might want to type it into your calculator just to see what you get. But I know that 1 divided by negative 0.5, that's the same thing as saying negative 2. This is the next weirdest one. I'm going to put a star next to this guy here. You might want to remember this coming up here. And that's a horrible looking star, but let's try that again. When we have x equals 0, and you have a reciprocal function or a rational function, when you go 1 divided by 0, your calculator is going to error out. That error is what we call an undefined answer. So undefined. Meaning there's actually no true answer there. You actually cannot graph that at all. But something undefined, we will add it to our graph physically, but you won't ever have an answer there. 1 divided by positive 0.5. Again, I'm going to use my calculator. I'm going to do a quick check on my calculator. It should be positive 2. And 1 divided by 1 should just be positive 1. Again, I would try to add on one more down here. I'd add on x value of 2, and that'd be 1 divided by 2, which is just a half, just an FYI. So I would add that on as well. So before we move on to function, domain, and range, let's try our best to graph this. So my first coordinate is at negative 2 for an x, negative a half. So that means I'm going right down here, negative 2 and negative half. I'm trying my best. It's in that ballpark. We're good enough right there. At negative 1, we're at negative 1. And notice at negative a half x, that's kind of right in between. Again, you're going to ballpark that. We're at negative 2. I have 3 coordinates. I can definitely connect my dots there. At 0, we're undefined, so I'm going to draw a dotted line. And this dotted line is going to denote that, hey, we're going to skip that. And that's what this dotted line really means on our graph is, hey, whatever our graph is, we're going to skip that dotted line. Our graph will never ever touch this dotted line ever. It's going to avoid it as best as it can. I'm going to continue on with my coordinates. So at positive a half, all the way up at positive 2. At positive 1, I should be at 1. And of course, at positive 2, I should be around 1/2 for a y value. And again, I have 3 dots there. Again, trying my best to connect my dots. So here's what it's going to look like. So I'm going to have a graph come in. It's going to run right below this x-axis. And once it gets to these coordinates, it's going to start curving and turning. So instead of running right below, we're going to start turning, going through this dot here, and we're going to go straight down. We're basically running parallel. We're trying to get closest to this dotted line here without ever crossing it, without ever touching it. Again, I'm getting to extend this just a bit. And again, this line here, we're never crossing or touching our x-axis as well. Up here, we're going to have a vertical line coming down, go through our 3 dots right here, 1, 2, and let's try our best to get through that 3rd one. There we go. It's going to keep going down. And again, this line here, it's always going to run right above that x-axis here and right beside this y-axis, never touching our x or y-axis. This is a reciprocal function. The very first thing we're going to ask is if I threw a vertical line going through this entire graph here, moving it left to right, does a vertical line ever touch this graph in more than one spot? The answer here is no, so that makes this yes, it's a function. What's my domain here? My domain is a little bit tricky for this example here. My domain as far left as I can go, because I have 2 graphs, by the way, I have 2 graphs, so I'm going to probably need 2 domains. As far left as I can go is negative infinity. We're going to go all the way up to 0 without including it. And then on the other side, we're going to start at the other side of 0 without including it, going all the way up to positive infinity. So what's my domain? My domain is x such that we're going to skip 0 because that's the only number we're skipping really. So I can say x cannot equal 0. That means I'm going to skip it, but, comma, but x can be an element of a real, meaning that it's going to be every other number except for 0 because we're not including it. For my range, again, I'm going to set up my range, so curly bracket y such that y cannot equal, y cannot equal 0, and y is an element of a real as well. So again, we're skipping 0 for y's. That's my set notation for this guy. Let's see if interval notation's a bit better. Just a hint, it is not actually. It's a little bit uglier. So sometimes when I have multiple graphs, like in this case here, I have two graphs graphed, I'm going to try my best to write it in set notation, but you should know interval notation as well. So let's talk about this one. Domain, how far left are we going? We're going as far left as negative infinity. How far did we go though? That negative infinity is going all the way up until we get to 0. We don't want to include 0 though, we're skipping it, so I'm going to put a rounded bracket, even though usually in the other examples we had a square bracket. I'm putting a rounded bracket. On the other side of that 0, where again we're not including it, but we're going to go all the way up to positive infinity. So here's my domain right here. I'm going to put this little letter u in between, meaning this is the union between both of these domains. So there's two pieces, two domains. I'm going to have a union saying that, hey, both pieces are needed in this domain. My range, as low as I can go, was negative infinity. As high as I can go was 0. Again, we're going to put a u there because there's two pieces, so I'm going to join it with this next piece at 0 all the way up to positive infinity. And there we go. We have interval notation done. For our last example today, we have f of x equals absolute value of x. That's what these two lines mean, is its absolute value. So let's see if I can get this going here. So this is AB. And hopefully absolute value sounds somewhat familiar from you. This is from Math 20-1, sometimes 20-2. Absolute value just means whatever that number inside those straight brackets there, because it is a pair of brackets, it's vertical brackets, whatever that answer is, it's going to come out always positive. So if I had negative 2 inside that pair of brackets, it's going to come out as a positive 2. Negative 1 is going to come out as positive 1, 0, 1, and 2 respectively. Okay. Again, I'm going to try my best to graph this. At 0, 0, I have a dot here. At 1, positive 1, and at 2, positive 2. Those are my first three dots. I also have dots at negative 1, 1, and negative 2, 2. I have more than enough dots to connect. I'm going to try my best to connect all my dots. And here we go. So drawing a line, connecting dots. Notice I chose the option that has an arrowhead on it. We want this arrowhead on our line here, meaning it's going to go on forever. And the same thing over here. Arrowhead on there, meaning it's going to go on forever. There's our graph. We are done. So the question right now, is this a function? Of course it is. We only ever crossed this graph one time if we used a vertical line test. So yes, it's a function. What's my domain here? Well, my domain is everything to the left and everything to the right. Well, as far left as we can go, negative infinity. As far right as we can go, positive infinity. Thus meaning x is an element of real. We're everything that x can be. For our range, what's our lowest that we went here for our range? Our range, the lowest that we went was 0. The highest we're going, well, to infinity. So for my range, I'm going to set up y has to be greater than 0. And y is an element of a real because there can be any number greater than or equal to 0. I'm going to use curly brackets to close that off. To finish this off, we're going to write this last example in interval notation for domain and range. So my domain xer is going to go from negative infinity to positive infinity, rounded brackets once I see infinity on there. For my range, the lowest I went was 0, the highest I went was positive infinity. I already goofed On this side here with 0, it shouldn't be rounded brackets. It really should be a square bracket because we want to include 0 in our answer. That concludes today's lesson on the 6 basic types of graphs.